I am Tangashakti, Assistant Professor from EEE Department, Rohini College of Engineering and Technology. Subject code is EE8591 Digital Signal Processing. In this video, we are going to see about the realization of FIR and IAR filter. So, from this session, the students can able to understand the realization of IAR and FIR filters. So, before that, we should know what is meant by FIR filters. So, the filters have a finite impulse response function. Means it's having the finite length of time. Next, the output of the filter is simply the convolution of the impulse response and the input signal. Next, we are going to see the properties of FIR filter. So, the properties of FIR filter, first one is stability. So, this means the filters are stable. When we are calling this filters are stable means for every bounded input, it produces bounded output. And also the poles are located at the origin and or within the unit circle. That's why we are calling this is a stable system. Next one, feedback. So there is no feedback for this kind of filters, which in turn means the rounding error are not compounded by some iterations. The error repeats in each of the iterations. For this, the implementation seems simple. Third one is linear phase. It's having in phase. It's used in the in phase sensitivity applications. So next one, advantages of FIR filter. So first one, it will be very simple to design and delay the input signal without altering the phase. That's why the calculations are simple and it needs single instruction for looping. Next, it's having multi-rate applications where you see interpolations and decimation are both, which in turn related to the computational efficiency. Next one, the FIR filters have desirable properties like numeric properties. That means the finite precision filters are implemented in DSP filters. And the fractional, fourth one, the fractional arithmetic implementation can also be applicable in this type of filters. Here, next we are going to see the FIR filter realization. Here we are going to see direct form realization of FIR system and a cascade form realization of FIR system. So here, the direct form realization of FIR system, we have to consider the difference equation. Okay, for any realization of FIR system, first we have to write the difference equation governing the FIR system. So here y of n is the output function, output. So that can be written as y of n equal to sigma m equal to 0 to n minus 1 bm x of n minus m. On expanding this equation, we will get b0 x of n plus b1 x of n minus 1 plus b2 x of n minus 2 up to bn minus 1 x of n minus 1. Next, we are taking the Z transform. So, when you are applying Z transform, we will get y of Z equal to b0 x of Z plus b1 z power minus 1 x of Z plus b2 z power minus 2 x of Z plus b3 z power minus 3 x of Z up to bn minus 1 z power minus n minus 1 into x of Z. For any realization of FIR system, first step you have to write the difference equation governing a system. After that, you have to write the Z transform for that difference equation. Then only we can realize the FIR system. So here the direct form structure provides the direct relation between time domain and Z domain equations. So this equation is nothing but the Z transform of the differential equations governing the FIR system. So here now we are going to realize this equation into the structure. We are going to make this equation into a structure. So listen, so here first term B0 into x of z. So here x of z is the input signal. So here we are writing x of z and y of z is the output sequence. X of z is the input sequence and y of z. So here in this equation first you see this term B0 into x of z. Okay, so here x of z, next we are multiplying with one constant, so that is B0 magnitude. So here x of z goes to the B0, its output will be B0 x of z. Okay, so we will get first term B0 x of z. So this term is given to this adder, right? Okay, so B0 x of z plus. Okay, so next we have to make B1 z power minus 1 into x of z. So for making this term we have to give the input sequence to the delay. Okay, so x of z into z power minus 1. So you will get z power minus 1 into x of z. So that is z power minus 1 into x of z. So this term is multiplied with b1. You will get b1 into z power minus 1 into x of z. Again it will be added to the adder, right? So these two terms are added. Again we have this term. Okay, so like this finally we will have bn minus 1 z power n minus 1 x of z. Okay, so we have to add one by one term. So here we have in between so many terms. So here we have number of terms will be there. So finally you will get y of z. Very clear? So next we are going to see the cascade form realization of FIR system. So for the cascade realization of FIR system, I have to consider the transfer function. So the transfer function h of z equal to y of z divided by x of z. So we can write b0 plus b1 z power minus 1 plus b2 z power minus 2 up to bn z power n minus 1 z power minus n minus 1. So this transfer function of FIR system is the n minus 1th order of polynomial. Okay, so this polynomial can be factorized into first and second order factors, and the transfer function can be expressed as the product of the first and second order factors. So we can write h of z equal to y of z divided by x of z equal to h1 of z into h2 of z up to hm of z. Okay, so this equation can be written as pi I equal to 1 to m h I of z. So this equation can be written as like this. So next we know that h I of z equal to COI 0i plus C1i z power minus 1 plus C2i z power minus 2. So once again for the cascade realization of FIR filter, first you have to write the transfer function. Next the transfer function can be factorized into first and second order polynomial. After that we are writing like this. Next we are going to implement this transfer function in a structure. So listen, so here h I of z equal to c non of I plus c1 of I z power minus 1 plus c2i z power minus 2. So this term h transfer function can be arranged in a cascade form. and individual second order or first order sections can be realized in either direct form structure or linear phase structure. So the overall system is obtained by cascading all the individual sections. So here we have first section H1 of Z. So this is the common equation, Hi of Z equal to C non I plus C1I Z power minus 1 plus C2I Z power minus 2. So here H1 of Z means H1 of Z equal to C non 1 plus C1 1 Z power minus 1 plus C2 1 Z power minus 2. So this individual section, the individual section can be represented as the individual direct form structure or linear phase structure. So here H1 of Z. So here first term C non 1. So here we are X of Z is the input and Y of Z is the output. So X of Z is multiplied with C non 1. So this term over. Again we have C1 1 Z power minus 1. So here we have one delay. So this delay, when X of Z is multiplied with Z power minus 1, Z power minus 1 and C11. So you will get this second term. Again this value is multiplied with Z power minus 1 delay. We are giving this input to the delay. So you will get C21 Z power minus 2. So all the terms are added together. Okay. So Hi of Z equal to C non 1 plus C11 Z power minus 1 plus C21 Z power minus 1. Okay. So for like this we have to implement H2 of Z term up to Hm of Z. Okay. So next one, Iar filter. So the Iar filter means is nothing but the infinite impulse response filter is a recursive filter. That means the output from the filter is computed by the current and previous input and also the previous output. So here this filter uses the previous value of output. So here we are using the feedback in the output of the filter. Next we are going to see the Iar filter realization. So first one, direct form, one structure of Iar system, cascade form realization of Iar system, again parallel form realization of Iar system. First one, direct form, one structure of Iar system. So here also we have to consider one difference equation governing an Iar system. So we know that the Iar system contains both previous input and output. So we can write y of n equal to minus sigma m equal to 1 to n a m y of n minus m. So this is the previous output plus sigma m equal to 0 to m b m x of n minus m. This is the input. And we can expand this equation. You will get y of n equal to minus a1 y of n minus 1 minus a2 into y of n minus 2 up to minus an y of n minus n plus second term b0 x of n plus b1 x of n minus 1 up to bm x of n minus m. Next you have to take the Z transform. So when you are giving the Z transform, you will get y of Z equal to minus a1. So here y of n minus 1. So here we have the time shifting property of Z transform. So we can write Z power minus 1 into y of Z and minus a2 into Z power minus 2 into y of Z. And like this minus a n Z power minus n into y of Z. Next b0 x of n. When you are giving the Z transform, you will get b plus b0 x of Z plus b1 Z power minus 1 x of Z up to bm Z power minus m into x of Z. So next we are going to see the direct form structure of Iar system. So here for drawing the direct form structure of Iar system, first you have to write the Z transform of the output equation. So y of z equal to minus a1 z power minus 1 y of z minus. So we know the different is the transform of this equation. Next we are going to implement the equation in a structure. So listen here, x of z. So we know that x of z is the input and y of z is the output section. So first we have the term minus a1 into z power minus 1 into y of z. Okay, so here this term will be here y of z. So here we have the y of z into z power minus 1. Okay, so the output is given to the delay. So you will get z power minus 1 into y of z. Next, this term is multiplied with minus a1. Okay, so magnitude minus a1. So you will get minus a1 into z power minus 1 into y of z. So this term over. Okay. So next, second term minus a2 into z power minus 2 into y of z. So this same value is given to another delay z power minus 1. So you will get z power minus 2 into y of z. Again this value is multiplied with minus a2. Okay. Again this term, so you will get minus a2 into z power minus power 2 y of z plus. Okay, so this term is given to the order. Okay, so you will get minus. So on adding these two terms, you will get minus a1 z power minus 1 y of z minus a2 z power minus 2 y of z. Okay, so up to a minus an z power minus n y of z, we can get like this. So this section represents the equation of these terms. Again you have to represent the remaining these terms. Okay, so here we have x of z. So the x of z here, it's given to the delay. Means you will get z power minus 1 into x of z. Z power minus 1 into x of z. So this term is multiplied with the magnitude b1. So you will get b1 z power minus 1 into x of z. So this term over. Before that we have one more term b0 into x of z. So for getting b0 into x of z, we have to multiply with b0 into x of z. So b0 x of z. Next one more term b1 z power minus 1 x of z added here up to bm z power minus m into x of z. So for all the values are added, so you will get y of z. So next one, cascade form realization of Iar system. So h of z equal to y of z divided by x of z. So we can write h1 of z and h2 of z into hm of z. So you can get phi I equal to 1 to m hi of z. So here hi of z equal to c non I plus c1 I z power minus 1. So this is the transfer function of the system. For cascade realization of Iar system, the individual transfer function of the system are cascaded to get the output. So next, parallel form realization of Iar system. So here, so the parallel form realization, h of z equal to y of z by x of z equal to c plus h1 of z plus h2 of z up to hm of z. So here c plus sigma I equal to 1 to m hi of z. For second order section, we can write hi of z equal to c non I plus c1 I z power minus 1 divided by d non I plus d1 I z power minus 2, like this. Next, for first order section, you will get hi of z equal to c non-I divided by d non-I plus d 1I z power minus 1. Okay. So here we can write, so this is the parallel form realization of Iar system. So here x of z, so first we have c plus h1 of z plus h2 of z. So first term c, this added with, it's given to the adder again h1 of z. First h1 of z added, again h2 of z, like this hm of z. So here each and every transfer system is represented by direct form structure. So all are added to give the parallel form realization of Iar system. Thank you.